All right, now that we've taken a look at a lot of the different programs that are out there available for free, that you can try on both PC and Mac, so forth, I want to take you through many of the more advanced programs that you would have to pay to use. These are ones that most of the professional musicians and sound designers will work in these programs in the film industry or in the music industry or sound design fields in general. So the one I'm going to take you through 4 or 5 programs right now, just to kind of show you the ones that some of these you could download yourself. They are free. Many of them you'll have to save up some money and purchase later. This is one that I use quite a bit. It's a system called Kyma. This has an external hardware component to it, so it's a little bit more expensive system. It's been around since 1990. It's a little bit different philosophy than some of the other programs that I'll be showing you, but this one is a self-contained unit that has a lot of great features in it that I find useful in doing any kind of work in sound design, sound analysis, composition. Real-time live interactive programs are really great with this system. You may find some of this in wherever you are. You may find people who have this at a university or maybe in a film studio or so forth. So this is the website. It's distributed by a company called Symbolic Sound, which is in Champaign-Urbana, Illinois, in the U.S. And this is sort of an example of some of the screen you'll see. I'll take you through a few of the features of this real quickly. I'm not going to give you a full outline of this, but here's just the web page that shows you some of the components of it. So what you've got in this is what's called a sound browser, which I'll show you in a second. It's a list of, on your hard drive, of perhaps thousands of different pre-made sound patches and sound files that you can start utilizing as soon as you get the program right away. So you don't really have to learn much about this before you can start doing fairly sophisticated type programming and sound design from this list of sound browsers, which I'll take you through in just a second. It also, anytime you load a particular patch into the program, it often will pull up what is called a virtual control surface. Anything that has a variable in it will allow you then to pull up these slide faders, which are assigned to any variables in the particular patch, which you can use manually, or you can assign these to external controllers, such as MIDI controllers. It comes with a great iPad program, which is a wireless program that will go through Wi-Fi. So most of what I'm doing right now is with my Kyma system is running through my iPad, and anytime I load a patch, then all of these particular slide faders will show up in the program on the iPad, so I can just use the iPad for controlling all these and controlling parameters of the sound. So that's in what's called the virtual control surface. Moving on down, the virtual control surface will have all sorts of different things depending on the patch that will pop up that gives you really great real-time control over this. There's another tremendous feature in Kyma, which is a timeline. This looks like a sequencer timeline. It really is quite a bit different than that. And I'll demonstrate this in just a second. The timeline will be moving left to right like this, but these are not tracks recorded. They can be recorded tracks, but most of these are patches themselves, which are turned on and or off given the length of time that they're specified here. And you can drag these, make them longer or shorter. And you can also pause the thing with what's called a wait until object, which will allow you to run the program at your own pacing, which I'll show you in just a second. So you can add as many tracks as you want to this and specify the output to 8-channel output and so forth. And then there are parameter mappings at the bottom of that where you can assign each of the variables to another particular element. So you could take the frequency of one particular sound file and you could drag that into here, and then that would be controlling the density or some other parameter of this. So it's very easy to interchange different kind of parameters in how each element controls another element just by clicking, dragging into this parameter automation file. I know I'm going quickly on this, but I just want to give you a hint of what's possible here. Any of these sound files that we open up, we can click on them and we will see the editor patch, which shows you going from, unlike Macs and PD, which tend to be from top down as far as the flow. This is more like the old analog synthesizer arrangements, which really goes from left to right. So when we look at this patch, the rightmost object goes to the speaker. That's the last one. So we can see that we start with, in this case, a live input object, which would be either a microphone or some kind of RAM object perhaps. Then it is fed fed into two different sources here, then they eventually end up going into this final invert spectrum object and going to the speaker. So these objects can get very complicated in the editing, but you do have an easy way of editing things in this what's called the signal flow editor there. And then down here you'll see, as you click on one of these objects, each of them will have variables. And the variables down here, anytime you put an exclamation point in front of a variable, it will then show up in your virtual sound control as a slide fader that you can control real time. So that's what, it's real easy to assign certain variables to things that you want to pull up in real time. Then the prototypes, this is the building blocks for all the different patches, and there are several hundred of these in different categories. And so the prototype window usually is at the top of your screen, and you can click and drag these into there to build up or replace some objects with other prototypes, and it's very easy to edit very complicated, sophisticated pieces very quickly on this. Moving down, there are a lot of other tools and editors. There's a lot of analysis tools, spectral analysis. You've got a built-in tape recorder. You can do different kind of analysis systems here, which I won't get into too much. Then you see here is a spectrum analyzer, which you can do different kind of analysis routines through here. And then here is the external hardware box I was talking about. It's called a Pacorana. It's the sound computation engine, which you have to plug that up to a separate audio interface. So if you have a standard third-party interface, it will then plug into this, and your audio goes through that interface into the computer here. But it's these two different devices that you would need to be running. So I use Kyma pretty much in every composition and sound design that I use today. You can also go to, if you sign up for them, you get to, there's a wiki site here, which has a lot of information about sharing different kinds of tutorials and sound files that are shared by lots of other users that use Kyma, so you can go in and download different sounds that other people have created and so forth. So it's really a fantastic kind of a user-friendly system here. So let me just take you over quickly to the Kyma system and just give you a demo for that real fast here. So I've already opened up the program here, and you can see over here, this is the sound browser window I was telling you about, where we have hundreds of different effects and so forth in various categories that we can pull up in our Kyma folder here. Under the sound library, there are literally thousands here. If I just pull up one folder, the effects processor, we can click on any of these and just see a number of, if I look at delays, there's various kind of delay settings that are in that. Different kind of equalizers that we could use up. You can see here there's just scores of different settings for equalizers that we already have made. Granular processing, which we've talked about a little bit in the class already. So if I just pull up something like Spectral Processing Live, which I'm open here, and when you see these, you can just highlight this, and by hitting the play button, it will compile that. And then if there are variables assigned to the virtual control surface, it will pop up on the screen when you compile that. So when I hit that, we see that it starts to play. You can change the variables on it. Change the density. All these are variables that can be assigned to the iPad or some kind of external controller. Different kind of devices will be used. A Wii controller you can assign to this, or pen tablets, Wacom tablets, so forth. So there are many different kind of variables you can assign to this. You'll see there are different presets that we can pull up automatically for that. You can randomize the settings. It'll keep coming up in new settings and so forth. So as you can see, it was very easy to assign that. We can also assign this to a microphone input if I want to have microphone control some of the sound on this. If I go back to here, and let me just, while I'm here, open this up and show you. If I double click on this, then we see the edit window for this patch. Let me make it a little bit smaller so you can see all the different settings here. So you can see the different things that have gone into making this patch. We don't really have to edit this at this point. We're just kind of seeing what's there. You can see up here in the prototype window, if I wanted to click one of these and drag it into here, I could change out some of these just by changing different categories. There are hundreds of prototypes here for editing that. So this is a very easy way to do live processing with Kyma here. So a very simple system here. Let me quickly move over and show you a timeline very quickly. Pull up one that's already pulled up. So, oh, wrong one. Where did it go here? There we are. So this is a timeline of a composition that I was working on recently, and you can see here that what I have done is, let's say, any of these particular. I'll just drag one randomly here from my sound browser. If I like to use a spectral chorus, I could just drag this into my timeline, and then you'll see it appears there. Then I could assign it to a certain length of time. I could have it move anywhere I want. So what will happen is, as this timeline moves, it won't trigger that particular patch until it gets to this point in the timeline. So then when I double click on that, I see the editing window for what I just was looking at. Here is the full complete patch of that. If I wanted to use that, and it's real easy to, if I don't want to use that, just click on it, hit delete, and it goes away. So what I've done, I've dragged quite a few different patches into here. Some of these are surround sound going to various channels. So the thing will be playing starting here at the beginning. But what I've got here, I've got these what are called the wait until objects. And when you look at a wait until object, what it is going to be waiting until there's some sort of MIDI key down that will then trigger this to move on. So what will happen is, when this starts to play, when it gets to a wait until, it will stay there and it will continue to play these patches until I hit, in this case, a MIDI key down, and then it will continue to move on to the next wait until, and then it'll continue to move on. So if I open up just a for example, just a fake keyboard, then I can move my wait untils. So all I have to do is hit the space bar to compile this, and you'll see it takes a second because it's sending all this data to the external hardware interface, the Pacarana, and once it compiles there, a few tables that were too long there, but that's all right. So now it's essentially compiled, which means it's very stable. It doesn't really use much of the computer processor at this point. It's only using pretty much timing code off the computer at this point. Most of the majority of the work is being done on the Pacarana unit itself. So you see the wait until is allowing it to stop until I'm ready to go. So if I come down and move my fake keyboard over here, so we can show you when I click that, then it will start to move. If I pick up my microphone, I do have microphone input into this. So test 1, 2, test 1. You can sort of hear some of the surround sound that is going on here in this. If I want to jump around a little bit, I'm going to skip over this just to show some time and go to, see it's moving forward. And next I will go to what's called a spectral chorus. Testing 1, 2. And when it gets to the chorus, you see it changes in the virtual control surface here, any parameters. And notice when it gets to a wait until object here, it stops. Everything's still playing. Testing 1, 2, test 1. So this is actually a morph. Now the spectral chorus is behind there. So if I want to morph this, testing, I can change the interval of the morphing. Testing 1, 2, testing 1, 2, testing 1, 2, testing, testing, testing. So let's move ahead. If I hit my keyboard, you see it starts to move there as soon as I trigger to go ahead. And what it will do, it will move over to the next particular object, sound object. This is called tracer. I can move this into a lower threshold. What it'll do is create a sort of tracing of different kind of spectral filters involved in this. Test 1, 2, test 1, 2, a lower threshold, a little bit more input coming in. I can change some of the parameters of that, so forth, so forth. Let's keep it moving forward. Hit another note, and it'll just keep moving through the timeline. Test. We have another patch coming up. Test. This will trigger, as I sing chromatically, it will trigger various samples that are in the setting. Do, 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 do. As I do a chromatic scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3. So as I move to certain parts of that, there's samples that get triggered by certain frequencies of that. Moving ahead, we move into a Cloud Bank synthesizer here. Test 1, 2. So this is being triggered off the amplitude of my voice. Testing, as you can tell. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Change the grain durations. 1, 2. Change the duration jitter. Change the frequency jitter. Okay, we'll keep moving on. So you can see, you can put as many of these kind of different kind of sound objects in your timeline and schedule them to happen, to occur at certain times throughout the piece. So this one has, here again, more of a granular synthesis kind of patch going on here with some rhythmic accentuations happening. So a lot of fun, different kind of patches I've thrown together in this one. So this is just a good example of how you would use a timeline. What's wonderful about this is you can not only set the wait untils to handle MIDI data, but you can have them set frequency or amplitude or even a spectral threshold so that you could be waiting for a certain note to occur or a certain kind of instrument to come in, and that would trigger this to move on. So you can have live input and have this thing assigned to respond to what's happening in the composition. So that the timeline is really unusual in any of these programs that I've seen, to be able to have this responsive as this to what's happening in a live performance without really having to have another real-time operator running this. So that's just a good example of the timeline. If I want to then take you very quickly and just show you a few other things over here real fast. If I move on down, for example, in the sequencers, there's a lot of different interesting drum machine kind of patterns if you're interested in making some of these. Let me just maybe try this one. So you'll see here, this is same kind of thing. We just pulled in certain patches into this, and if I compile, and you'll see here, this is a 16 stage drum machine, basically. And what I'm going to do, I've got all these that I can turn on or off, but it's much easier to do it from my iPad. So if you sort of look at the camera here, you'll see in the iPad I've got the same things that appear here as soon as I compile that show up here. So all I've got to do is just keep touching these to change the parameters of that. So it's much easier to do it from the iPad. You can change the swing amount, change the BPI, beats per minute. Then you also have a lot of different presets. Go into a triplet field. You can randomize again. Okay, so there's a lot of different drum machine kind of patterns here that make much more sophisticated and much more variable drum machines than you'll find in most programs. You can see there's just a lot of interesting kind of, these are not the only ones either that are available here. Also, I mentioned getting into, let me just quickly move down to, if you wanted to do some analysis, if we get into some of the spectral analysis that's already been done on this. Let's see, here are some that I was doing recently. Here is a recording of this is a analysis, resynthesis of a vocalist in a Japanese puppetry form called bunraku, and you can sort of see here the resynthesis of this with all the overtones in that. You can do lots of things to extract, once you've got all these sine waves there. If I want to, for example, select only the odd numbered overtones, all different kind of possibilities. If I just want to highlight these overtones on the lower end here. So a lot of different great analysis programs here that you can do with this. So this is just a real quick kind of overview of Kyma. There are many other timelines that come with the program when you buy this. Let me just randomly click on one here so you'll see if I compile this. These are ones that are already set up. So there are literally thousands of different things that you can start to explore with Kyma. Both from the analysis standpoint and from the compositional standpoint, but lots of real-time capabilities on this, and lots of different ways of interacting with different devices on this. So this, as you can see, I find this one to be very powerful, and I've used this system since it first came out in 1990, I think, was when it first developed. The developers of this I actually went to school with, so I know them quite well. So that's the Kyma system, and I hope you have maybe a chance to explore one of these if you ever get a chance.
The preceding program is copyrighted by Emory University.